Number 15 is very similar. We need to find the slope, we need to find the y-intercept, and we need to plug it in. Except this time it tells us that we're perpendicular to the line y equals negative 1/2 x plus 2. So this time the slope of this line is a negative 1/2. But since we're perpendicular, we want the opposite reciprocal. So instead of negative, it's going to be positive. Instead of 1/2, it's 2/1. Okay, so I change the sign and flip it, which is really just a 2. So now I start with a fresh y equals mx plus b. And I plug in what I know. I know that the slope is 2. I know that I have an x and a y value listed right here, this ordered pair. So I plug the 2 in for x, I plug the negative 1 in for y, and I would just have to solve for b. So here I have to subtract the 4 from each side. So I find out that b equals a negative 5. So now my equation would be y equals 2x minus 5. Find the slope, find the y-intercept, plug it in. In number 16, I'm doing the same thing again. I need to find the slope and the y-intercept. Since I have two ordered pairs this time, to find the slope, I'm going to do my change in y over change in x. So here, y was a negative 2. Now it's a positive 5. Y has gone up by 7, so it's a positive 7. X was a negative 3. Now it's a 0. X has gone up 3, so that's a positive 3. And this one just stays as a fraction. It's 7/3. I still follow the same procedure as I did before. Y equals mx plus b. So I start with a fresh y equals mx plus b. Let me show that. And I plug in what I know, 7/3. And now an x and a y value, I can choose either one of these points. I'm going to choose the second one. And why would I choose the second one? Because that is the y-intercept. Look, 0 for x, 5 for y. I plug it in, b equals 5. And really, with this one, I don't even need to show this step that I showed over here because the y-intercept is given. It's a 5. So always look for those shortcuts. Y equals 7/3 x plus 5. All right. Either way, you should be able to come across the correct answer, regardless of whether or not you see that shortcut. Okay. For the next one, we're plotting my age versus the number of hairs on my head. So what we want to do here is we've got to scale this. I need to go from 18 to, I'm going to start here with 18. Let me extend the page a little bit. And maybe I'll go 3, 19, 20, 21, 22. Again, I want to use as much of the graph as I can. I could have spread that out a little bit more. This should be all right. And now the hairs on my head, I'm going to put a little zigzag in here to say that the graph is condensed. I'm going to start somewhere around 70. And maybe we'll do 80. Well, I could spread that out a little bit more. There we go. And now I just have to plot each of these. 18, 101 would be somewhere around here. 19, 100 would be somewhere around here. 20, 91. So I'm just plotting each of these. 2182. And 2273. Right around there. Okay? And now what I want to do is I want to construct a line that models this data well. And I don't want to use like the first 2 points here. The first 2 points wouldn't give me a very good representation. They don't follow generally what the points are truly doing here. So my recommendation is to maybe ignore that first point because it looks like it might be some sort of outlier. And I would choose one of these other 2 points, maybe the 19-100 and the 20-91. Okay, so I'm going to go with those 2. You can choose 2 different points, and you might get similar results. Hopefully for this one, it should be pretty close to the same. So here, really, I'm looking at the ordered pair 19-100 and the ordered pair 20-91. I mean, that's what these are as ordered pairs, and I'm asking you to find the equation of the line. Well, I need the slope, and I need the y-intercept. The slope, I just have to do my slope formula, the change in y over change in x. So let's see, y was a 100. Now it's a 91. It's gone down 9, so that's a negative 9. X was a 19. Now it's a 20. It's gone up 1, so that's a positive 1. So my slope is negative 9. From here, to find the y-intercept, to do the same thing that I've always done, I start with a fresh y equals mx plus b. And I plug in what I know. I know that the slope is negative 9. And now I just need an x and a y value to plug in. Well, I have an x and a y value. Okay, I've got two of them. I'm going to use the second one, the 20 and the 91. And now we just have to plug this in. That's 91 equals negative 9 times 20 is a negative 180. And now I just have to add the 180 to each side. So I find out that b equals a 271. So that's my b value is 271. So my equation, my prediction equation is y equals negative 9x plus 271. And the thing that it asked me to predict, if I look up at my chart, is I want to predict how many hairs are going to be left when I'm 30. I want to know what I have to look forward to. So I'm going to plug the 30 in here. Y equals a negative 9 times 30 plus 271. So negative 9 times 30, that's going to be a negative 270. So plus the 271, so that's going to equal 1. And that doesn't mean one hair left on my head, because remember, this is in thousands. So I've got 1,000 hairs left, so let's not jump the gun. I've got still more than Homer Simpson, which works out pretty well for me. Okay? For this page, we're just matching. We've got to match the graph with its equation. And I'm going to start by looking at the graphs, and then we'll find the equation from there. In number 18, I've got a y-intercept of 3. So I know there's going to be a plus 3 at the end of this equation. Then I just have to count the slope. It looks like I go down 1 over 2, so that's a slope of negative 1/2. So I'm looking for y equals a negative 1/2 x plus 3. And it looks like that's letter C. So number 18 is letter C. In number 19, again, I start with the y-intercept. The y-intercept looks like it's right here at 2, so it's a plus 2. And then I just have to identify the slope. The slope looks like it goes up 2 over 1. So up 2 over 1 would be a slope of 2, so we're looking for y equals 2x plus 2, which is letter F. So number 19 is F. Number 20, again, I look at the slope, or the y-intercept. The y-intercept is down here at negative 4. So now I'm going to have a minus 4 at the end of this equation. And now I just have to identify the slope. It looks like I go up 3 over 1. So that's a slope of positive 3. So I'm looking for y equals 3x minus 4, which is letter A. Number 21, I've got a y-intercept of negative 4, so I put the negative 4 down. I've got a slope that goes up 2 over 3, so up 2 over 3 is a slope of 2/3, so it's y equals 2/3 x minus 4. Y equals 2/3 x minus 4 is letter E. Number 22, it's a horizontal line. Remember, horizontal lines are always y equals equations. And in this case, the y value that I'm consistently staying at is negative 3. So it's y equals negative 3. And again, that's like a slope of 0. So this one is y equals negative 3, which is letter B. And now the last one we have, again, I've got a y-intercept of 2. So it's a plus 2. I've got a slope that looks like it goes, let's find a point that it goes through. Looks like it goes up 4 over 3. So up 4 over 3 in the positive direction. So y equals 4/3 x plus 2. So 4/3 x plus 2, that's letter G. So the last one is letter G. And that's it. So identify the y-intercept, identify the slope, and match it up with the equation.
In number 25, number 24, we just want to graph this equation of this line, and remember here we've got the slope and the y-intercept. So we start with the y-intercept. It's at a -4, which is down here. And then we use our slope, which is 2, so I go up 2 over 1, up 2 over 1. And I draw the best line that I can draw. And that's it. Okay, so again, slope, y-intercept. Start with the y-intercept, then count out the slope from there. For number 25, really this is kind of a linear equation, but it's an absolute value equation. Remember, the absolute value equations are the ones that form the v. And the first thing we want to do is find the vertex. Okay, that's where our v starts. And for this one, remember, it's of the form y equals a times x minus h, or the absolute value of x minus h plus k. So when we see x and then a -3, the x matches the x, the minus matches the minus. The h is actually a +3, and then the k value is a 4. Okay, so I start at 3, 4, which is up here. That's my vertex. And then I look at the a value. Right here, the a value is a negative, which means this is going to open down, so my v is going to open downwards. And the fact that it's a 2 means it's going to be stretched vertically, which is going to make it look skinnier. And essentially, it's going to kind of use a slope of 2 and of -2 going in each direction. Okay, so we get those two versions of this line that form this v. If I look at this one, with inequalities, really we just do this in two distinct pieces. We graph the linear aspect of this thing. So if I think about the linear component of this, I'm just essentially ignoring the inequality sign and saying, okay, y equals a -1/2 x plus 3. That's what I want to graph here. And that's got a y-intercept of 3 and a slope of -1/2, which is down 1 over 2, down 1 over 2, or up 1 back 2. And then from here, since this is an inequality, I have to look at this inequality sign. Since there's no equal to condition, it just says less than. Remember, when I have the less than or greater than symbols, I use a dotted line. And when I have the less than or equal to or the greater than or equal to, I use a solid line when I'm graphing. So for this one, I'm going to use a dotted line. So I used a dotted line here. And now I have to choose a side to shade, because that's what this does. That in terms of the greater than or less than, I have to shade one side or the other. And to do that, we just pick a test point. I would test to the point 0, 0 when you can. So I plug a 0 in for y. I plug a 0 in for x. And I simplify, and it reads as 0 is less than a +3, which is a true statement. And since I got a true statement, I'm going to shade that side of the line. Okay, so I shade that side of the line because it gave me a true statement. Okay? And that's the graph of my inequality. For number 27, this is also an inequality, but it's an absolute value this time. So once again, I'm going to think of the linear component of this thing, which is just the absolute value, which is exactly what I did in the problem above this in number 25. I'm going to think about y equals the absolute value of x plus 2 minus 1. So I start off identifying the vertex. The vertex, this one is going to be -2, -1. So I go -2, -1, which is right here. I look at the a value. The a value is the number out front here. I can't see it, but I know it's there. It's a 1, a positive 1, so this guy's going to open up. It's going to have a generalized slope of 1. It's going to be my standard width. And for this one, since I have an equal to condition, as discussed last time, I'm going to use a solid line. And now I need to pick a side of this thing to shade. Once again, I'm going to plug in a value. I'm going to choose 0, 0 and see if it works. So I plug a 0 in here. So I get 0 is greater than or equal to. That gives me an absolute value of 2 minus 1. So I get a 2 minus 1, which is 1. So now I have written 0 is greater than or equal to 1, which is ridiculous. So that point doesn't work, so I shade the other side, which puts me inside this V shape, inside the absolute value. And that's it. Hope this was helpful. And good luck on your test.